All right, kiddos, the third section is all about the international system of units. So we need to trade in our imperial system. So deposit your feet here and let's get ready to meter stuff. All right, so the imperial system is really kind of ironic that the United States and, Liberia and Myanmar are the only ones that use it. Um, because the imperial system is based off of the king. It's based off of, British rule. And, we are red, white, and blue, 1776, Declaration of Independence. We should not be using this imperial system. All right, back in the day, before it was completely standardized, the yard was the length of the king's arm, the foot was the literal size of his foot, and the pound was how many marbles he could pick up. All right, but with our metric system, we are using some sort of base unit, and then we have prefixes that are basically powers of 10. And the rest of the world is using it, so we really need to switch. So maybe you guys can make that happen as you get older. All right, so when we go visit family in Maine, since Maine is near the Canadian border, you'll see that the exit signs are not only in the imperial mile, but they are also in the metric system. So 1 mile is 1.6 kilometers. Um, a 3.1 mile course is going to be your 5Ks, your 5 kilometers. So you definitely have some exposure to this. All right, so the metric system is based off of Le Système International des Unis, which is French and is also called the SI International System, System International. In your textbook, there are 11 base units that are listed. You really don't need to know all 11, but the ones that you do need to know are going to be length, which is your meter, volume, your cubic meter, which is about the size of a washing machine, okay, making a meter, and a meter. In mass, it's going to be the gram. Density is grams per cubic centimeter. Temperature is the Kelvin temperature scale, and we'll get to that in a couple of sections. And time, which thank goodness we do use internationally as the same with seconds. Could you imagine if we used different kinds of units for time? There's no way we would be able to coordinate calls and flights and all that stuff. All right, so this is the way that the metric system works. There is some sort of base unit, okay, and the three most common ones we're going to use is going to be the gram, the liter, and the meter. And then you have prefixes that go in front of gram, liter, and meter. So these right here are all going to be bigger than one of the base units, and these down here are all going to be smaller. So let's take a look at what we have. All right, mega, which is capital M, is 10 to the sixth, or a million times a base unit. So like a megameter is going to be a million meters. Kilometers, little k, is 1,000 times. Okay, so when we saw that Y2K business back before you guys were born, all right, it was the year 2000. And if somebody says, "Oh, I make 75K a year," I make $75,000 a year. All right. Hecto is hundreds, so that's going to be 10 to the seconds. And deca is DA and is 10 times. So deca is bigger than the base unit. All right. Now, smaller than the base unit is going to be a deci, like a decimal. Deci is itty, all right, and itty bitty is 10 to the negative first, or 1/10. Okay, so deca is bigger, these guys are all bigger, and these guys are all itty bitty, like decimals. All right. Centi, like cents in a dollar. Cent, 1 cent is 1/100th of a dollar, so that's your 10 to the negative second. Milli is 1,000th. Those of you that speak French and Spanish, you should know that mille means 1,000. So milli means 1,000th. Micro is this weird Greek letter here called mu. All right, it's like an M and a U had a little baby right here. And that Greek letter is 1 millionth. Basically, they used up the capital M for mega and they used the lowercase m for milli, so they needed to go into Greek. And yes, we'll be using lots of Greek in our course. Nano is little n and kind of looks like 9 and Nano, and that's kind of where Apple got the whole thing for the Apple iPod Nano. And then Pico, Pico, is lowercase p, which is a trillionth. Some people say pico. Um, and here, Pico is your electric company, Pennsylvania Electric Company, and you pay that 12 months a year. So I like to think of that as, pico is 12 and 10 to the negative 12th. If you need help remembering all of those things, you can use a mnemonic device. Um, Many kittens hate dogs because dogs can't meow much nor purr. Okay, some people um, really find that helpful. You'll also see that the units for scientific notation, the values for scientific notation go down by threes, so 6, 3, and then you go count down 3, 2, 1, and then it mirrors -1, -2, -3, -6. So these guys are completely mirrored. And then you have your 9 and 12. And nano is 9 and pico is going to be 12. So mega, kilo, hectadeca, deci, centi, milli, micro, nano, pico. All right, to kind of show you that there are other options. You can also see that there are things like tera, which is going to be your trillionth, which is trillion, which is going to be like what we use for terabytes in computing. There's giga. There's femto, which is really tiny, 10 to negative 15th. Atto, 10 to negative 18th. There's all different kinds of units here. Yocto, zepto, all of those. But obviously we only are going to use what we use in class, and the previous examples are going to be the ones that you're going to see in class when we talk about size of atoms and all that kind of good stuff. All right. But the beautiful part about our metric system is that regardless of the base unit, they all use the same prefix. So meters, grams, and liters, which is going to be your length, which is going to be your mass, and is going to be your volume, are all going to use the same prefixes. So 1 meter is 10 decimeters, or 100 centimeters, or 1,000 millimeters. Well, the same thing is true for grams and liters. Okay, in our imperial system, we don't have that. What we use instead for length, we have inches. All right, and it's 12 inches equal to 1 foot. And for mass, oh, well, we have a pound. Well, it's not 12 ounces, it's 16 ounces. And that's totally different. For volume, we have 1 gallon, and that's going to be 64 ounces. All right, so we can end up seeing that these two things are definitely different. And in my opinion, this makes way more sense than our imperial system. Okay, so when we use all of these in the metric system, it takes a little bit of understanding, but with a little bit of practice, you'll be fine. Okay, the most common thing that you need to remember is that 1 inch is equal to 2.54 centimeters, so roughly 2.5, and it helps you kind of figure all of that out. All right. Lastly, we in class will send you on a little scavenger hunt where we are looking at lengths and masses and volumes. We're going to use a ruler, and you're basically going to figure out exactly um, what the imperial and what the metric equivalent is going to be. So you'll measure like a paper clip, and you'll measure the volume of a Dixie cup, and you'll weigh your phones on a scale, and you'll try to figure out how many ounces, pounds, grams, meters, liters, and all of that are going to be. All right, so please review all of our prefixes so that you know what centi and milli are going to be. The most common things to remember is that there is 100 cents in a dollar, 100 centimeters in a meter, and there are 1,000 millimeters in a meter. Mil is going to be your mita. So that, children, is our metric system.